Ok, d'accord.
Je vous montre, vous le voyez ici en fait, d'accord, oui, vous n'avez pas besoin de tout voilà. Ok.
D'accord, super.
Super.
Ok.
Je la laisse là.
Oui. Donc, c'est bon pour la présentation. Vous l'avez reçue.
C'est bien celle-là.
Oui, exactement.
Ouais.
Pardon. Javier, donne-moi ce fichier-là parce que tu vas en
Hi, Vianney.
Nice to meet you.
Nice to meet you. So we'll have a small change in the order of presentation. Fawzi will start, and then we'll follow the program. So if it's okay, you'll be served.
Sure.
Okay. But please have a seat. Hello, everyone. Please take seats. So I'm Vianney Dokiet. I'm very pleased to chair this session on socio-economic and environmental aspects of critical minerals. And as we are in a tight time constraint, I guess we will start right now. There will be a small change in the program, so Fawzi Banao will start. And then we'll follow the order indicated on the program. So we will have Osmel Manzano and Daniela Valdivia by Zoom. Then Jonah will present here, and then we will have Cahya, Danu, Rahman by Zoom also. So Fawzi, I'll let you with 15 minutes of presentation.
Thank you. Good morning. My name is Fawzi Banao. I am a researcher in development economics. My research is focused on public financial management, natural resources management, and political economy of fragilities and conflict. So it is in this goal that I want to present to you our research hotspot about mining and armed conflict in Africa. This is the plan of our of the presentation. So, at beginning, most of African countries are affected by several instabilities and armed conflict situation. And in this way, the empirical studies have propose some determinant of causes of armed conflict in African continent. And one aims popular theories about the causes of armed conflict. It is the natural resource causes. And this theory is very simple. More a country have an abundances of natural resources, and more is having probabilities to be affected by conflict. So, however, currently there are several authors that criticize these theories. Because at one hand, some authors defend, of course, the natural resources course, because, for example, Rahman al attested that mining activities at local level improve armed conflict in the African continent, but also the raising of the mineral prices improve the clashes. So. Despite that there are some authors that defend the natural resources theories currently, several authors also criticize. And in this way, for example, Bhattacharya and Mamo attested that the mining discovery not improve the onset of armed conflict. So it is globally in this context that our studies emerge. Because when we do global literature reviews, we observe that the authors don't take account of heterogeneity bias that can be raised at local level of the impact of mining on on armed conflict. And in this way, it can be raised a time barrier, varying confidence that can be created between meaning depositing, area with meaning depositing and area with no meaning at local level. Therefore, the goal of this research, it is to investigate, firstly, the effect of meaning on armed conflict, but in additive and control groups, to take in account of the existing of a local heterogeneity situation. And in this goal, we use as control group a area with discovery mean, but no active. So it is our supposition for the aims of the studies. So we contribute mainly by an empirically and methodological contribution. So our data have been extracted from several sources. About sources, we have used ACLE data, MINEX mineral deposit data set, but also for meaning prices, we use both World Bank data set and Rappaport report. One aims issue for the studies, it is to show that our control groups is a sustainable. And in this way, I want to present you these two maps. The first map shows the location of discovery and active mines, and the second map shows the location of conflict and area. And when we look at these two maps, we observe that the location of discovery and active means are nearly. And this attests that the means area and conflict are not randomly distributed around the space. And this is our first exploration about concerning the data. So now I present you a graph of the conflict frequencies distribute through the active means, the discovery means, and no means. And when we look at this graph, we see that the trajectory between discovery and active mean are similar, and this helps us to support our investigation about discovery mean as control group. So I present you also the statistics described about we use several variables to compare characteristics between.
Can you quickly explain the difference between minus mine, the Nordic Rona paper?
I don't understand. Excuse me.
There's this paper which came out this year in AER. This mine is mine. It's by Dominic, you cited it, but I would like to see what's the exact difference between what you do and what they do. Is it in the identification?
So comparing to this one immense paper, we additive the control groups. It is our aims contribution.
So that's the active versus not active mine. Is that the discovered mines which are not open? That's the control group. That's the novelty.
Yes, we additive these control groups with active mines.
Thank you very much.
So I present you the differences of the comparison between characteristics of active and discovery mines. And when, for example, when we look at the military spending variable, we see that there are some similar output about the variable. In this way, all this step, it is to to help us to better understand the use of the discovery mines as control groups. So to use the control groups, we naturally we can't use if the discovery mine have an impact on conflict. It is not a good control variable, and in this way, we implement an estimation about discovery mines and armed conflict in our sample, and we use treasury estimates. As a result, we find no significant effect. So it is similar, this hotspot is similar for the Batashari and Mamo, because they also find that the mining discovery have no impact on intrastate and conflict. And we find the same result. So in this way, we can use no other control variable to implement the regression. So about identification strategies, we discuss about all bias that can be raised against our estimation. For example, it can be a bias when we change the borders and we use a grade cell at 0.5 degree level. But also, we can be confronted to the endogeneity bias with opening and closing mines. And to resolve this issue, we use two different definitions of the mines. And in the next slide, I will present you this situation. So because when a mine is opening or closing, it can have inversely relationship with our estimation. So this is our models. And we use a binary variable for the conflict. And as I said, we applied two definitions of the active mine. So we name this variable keep. It is all cell where the mine is first active, as we write. And it starts as activities and never stop as activities until the end of the period. So the second variable we name force, because it is a pre-treatment. We use this variable as a pre-treatment period. But the mine closed during the sample and still consider active. It don't close as a variable. So we use treasury estimation. Secondly, similar as the paper of Berman and al., we also investigate the relationship between mineral price variable, variation, and the armed conflict. So here also we use two different definitions of active mean, but here we have no confronted to the endogeneity bias. Because we support that the international prices is no function of local activities of mining, and there are a low supposition that the local activities could be affected by or the international can be having reversely relationship with the conflict and prices. So, results. What is we find? Firstly, we applied the similar estimation, same the Berman and al., and we find the same results. More the mining activities improve, and more the conflict army in Africa also improve. However, when we additive our control variable, we find no significant effects in our estimation. It is the aims result, as we can say, of our estimation. So, secondly, about our regression, about the meaning, prices, variation, and conflict, when we use the estimation without control variable, we have the same result. We have the same result for the Rahman and al. However, when we added our control group, we have a falling of 20% from 30% to 40%. And we show that the using of control groups have a significant impact on the effect of meaning on armed conflict. And we discuss the results, and because the meaning prices is still positive impact on armed conflict. However, when we use meaning, we have no significant effect. We justify this result because the local level, the meaning international meaning price have no significant. I want to say that. At local level, the meaning prices is not sensitive to the armed conflict area, and this have still an positively impact, and because it is exogenous to the local interaction. So, to conclude, the time is over. Okay. To conclude, what is we must to understand? Firstly, the natural resources courses theories is criticized actually, but to contribute about this debate, we use a control groups as innovation, methodological innovation, to take in account of heterogeneity bias can be raised in the estimation. And we as policy recommendation also, our result is, we can say it is optimistic, because when we take in account of discovery, when the state taking account of discovery means it can reduce or avoid armed conflict by improve policies, by implement policies at local level to avoid clashes between population or armed groups. So it is an optimist, we can say, narrative. So I finished my presentation. Thank you.
Thank you. So we have some time for questions.
So thank you very much. This is very interesting work. I may not have understood it correctly, but let me try and ask my question. So if I interpret it correctly, you said that the mine opening effect from Rahman goes away when you use your new control group, which to me, but the price effect is still there, but is dampened somewhat. So to me, this sounds like you're saying it's less a mine opening effect and more a mineral presence effect, because your control group of mineral discoveries takes away Rahman's mine opening effect. So is there a story here perhaps to do with the presence of the mineral even in the absence of the mine, perhaps also causing some of the absence of the mine, whereby artisanal mining, which we know is sort of often linked to armed groups and even conflict, may be part of your effect here, that it's an artisanal mining aspect as well as an industrial mining aspect, whereas because of the way Berman used the data, it sort of was assumed to be an industrial mine to conflict effect, whereas you may be picking up something very interesting, which is this other artisanal dimension to that. Could you elaborate? Thanks.
So I want to say that we must differentiate crossing mines and discovery mines. Because if a mine is crosses, it has been activities and there are some exploitation that is already have been done. It is not the same definition compared to a discovery mine. A discovery mine can to be extracted or not, because there are several mines that have been discovered but not extracted because the government or the mine is not satisfied for the industry's extraction. So I think that it is one aims issue that we must to understand about your question.
Jim was asking about, is there... Thank you. Jim was asking about informal mining and whether what you're picking up is actually a proxy for unobserved informal mining. Could that be right?
Yes. Yes, it is. We take in account of, because the aims of the study, it is the time varying confounder can exist. And past studies have not taken account of these issues. And the mine have not the same, in the area, they have not the same products or the same structures. And it can be exist in time varying confounders. And when we use the control group, it is to take in account of this situation.
But that's, if that's right, it's really an important point, because as Jim said, Berman et al. Assumed that all the conflict was coming from the formal sector. But what you're suggesting is quite a lot of it could be coming from the informal sector. And that's, if that's right, it's an important, valuable new information alongside what you're doing on the other stuff, which is showing that it's less powerful effect than you thought in the formal stuff. It's still there, but it's less powerful. But the supplement that it might well be this unobserved stuff that Berman had completely missed. That's really important, I think.
Yeah. Exactly.
I have a technical question. Actually, yes, it's more a comment, so it's quick. I will abstain from making points about mismeasurement in mining data. I think I made my point yesterday. But you have a big measurement problem, which is 0.5 degrees does not translate into meters equally all over the continent. So for the non-spatial people, 0.5 degrees is about 55 kilometers on the equator and 0 meters on the poles. And there's a big difference. People don't travel across degrees, they travel across meters. So you might want to translate your degree to degree. I know people use it because it's simple, but it's incorrect because you don't treat space equally across your sample. So I think you should correct for that.
Thank you.
Thank you, Fawzi Banao, and we'll move to our next speakers online. Osmel Manzano and Daniela Valdivia. I don't know if you can hear me.
Yes, can you hear us?
Yes, we can hear you.
Okay, so just 1 minute so that we can see you on the screen and see your presentation. Okay, that's fine. So the floor is yours for 15 minutes.
Thank you for your invitation. We want to present an extension of previous work to focus on the role of institutions, in particular at a local level. Next, please. We will begin by providing some context, followed by the evidence we have gathered. Then we will show the impacts of the reform on the process of becoming a mining district. And finally, we have our conclusions. So for the context, in the scramble for critical minerals, Latin America stands out as one of the most strategic regions. The mining sector supplies essential materials such as lithium, copper, cobalt, and nickel, which are fundamental for solar panels, batteries, and modern electronics. Latin America and the Caribbean are global leaders in the production of these resources. In this context, Peru plays a particularly crucial role. It is the third largest producer of copper, the second largest producer of zinc, and the third largest producer of silver globally. Peru also produces tin and lead and has significant potential for rare earth elements. However, mining in the region has often been linked to local conflicts, as you can see. As Professor Rose has noted in his research, there are no civil wars or secessions. The sector has frequently been a source of disputes. Peru is no exception, as you can see, ranking among the countries with the highest number of mining-related conflicts. Projects such as Las Bambas have experienced more than 400 days of stoppage due to the global tension and protests. Access to resources has been, therefore, become a critical issue, highlighting the importance of dialogue, responsible practices, and community engagement, but also of the institutions. In previous work done, we have done surveys and experimental evaluations, and this is what we found. So first, people think that mining is good for the country. We call that an implicit license, meaning that the public accepts mining because its overall economic impact. However, many people feel that they do not receive the fair share. Also, we did sentiment analysis, and it is almost seen as a necessary evil. While people value the economic benefits, they are also concerned about the environmental impact and social trade-offs. When we ask about how mining revenues should be used, people consistently indicate that the funds should be directed to the regions where the mining occurs, reflecting a desire for local benefits and investments. However, governments at the local level have been a challenge. Firstly, we have different arrangements, federations and unitary governments. Federations have their own challenges and conflicts, and it is not the focus of our work. Osmel has written a couple of papers of these issues. However, as it can be seen, many mining countries in the region are unitarian with decentralized functions. So in this country, local capabilities often limit effective governance. In Peru, local governments only execute 68% of their budget on average. So the region has already seen reforms and reversals in revenue sharing mechanisms due to the capacity constraints. For instance, in Colombia, hydrocarbon revenue sharing rules were initially modified to limit the global government discretion, but later backtracked due to the pressure from local actors. So in Peru, the canon is a revenue sharing mechanism. It has been in the constitution, but it was only in 2001 that it was actually regulated. Subsequent reforms, including the introduction of a special mining tax and a special mining levy in 2011, were designed to adjust how mining revenues were allocated. Evidence. So in our research, we have conducted studies examining the role of mining in shaping key development outcomes, with a particular focus on education, as you can see here. One of the key areas we have explored is the impact of fiscal reforms on local development, including the 2011 tax reform in Peru. So the reform introduced new mining taxes and royalties, with the aim of improving fiscal efficiency and allowing for a more equitable redistribution of mining revenues. While the reform succeeded in increasing the overall revenue, it also led to unintended consequences, especially for municipalities where heavily rely on canon minero. So our findings show that these municipalities, which depend on mining revenues, experience a reduction in the canon they receive as a result of the new taxes. This reduction had a direct impact on local education outcomes and has led to a delay of approximately 1 year in improvements in testing performance. Therefore, our results imply a positive effect of revenue in education post-2011. For another paper, we tried to estimate the local impacts of large projects. In the case of Peru, there were Antamina, Cerro Verde, and Yanacocha. All of them are among the largest mines in the world in their minerals. The interventions were when the mine had started operated or when they changed ownership for the case of Cerro Verde. Since we use propensity score matching with census data are relevant. That's why we highlight it here. In education, we measure secondary enrollment, and we found negative long-term effects for Cerro Verde, positive short-term effects for Antamina, but no long-term effects. And finally, we found no effect for Yanacocha.
Okay, thank you, Daniela. So to continue, then we decide to move forward to the next stage, no? And as I was explaining, we take advantage that Peru has many natural experiments. First, in the first paper, we used the reform. In this paper, we use the fact that the rules, the way revenue is shared, is different depending whether you are a producing district, you are a province, or you are a region. So Peru has 3 different levels of subnational governments, no? And the rules are very different. So for example, if you are a producing district, you get a share no matter what. However, if you are a producing province or a producing region, the share that you get depends also on social indicators. No, so we explore that difference in the way the revenue is allocated, joined with geographic information. So we have georeference information of the mines and the school to try to disentangle the impact of mining activity and revenue. No, so that is this last paper that we call, is it the mine or the revenue? And overall, we find an interesting dynamic that the impacts are different in the short run compared to the long run. So usually, when you become a producing district, the impacts are positive in the short run, but are negative in the long run. And sort of the same happens if you are near to a mine, but usually the impacts of being near to a mine are smaller than the impacts of being in a producing district. So basically, in other words, the impact of the activity is less than the impact of the revenue. And we discuss in that paper the dynamics and find that the main channel is through the labor market and provision of public services. So what you see usually is that labor force participation, especially of minors, start to fall over time. And then you begin to see that in schools, the number of teachers to students begin to increase. And that's in particular because of the rules, how in Peru expenditure is allocated. So local governments can, for example, put water, put electricity in a school, but they don't hire teachers without the approval of the education minister. And they get, actually, the salary is not paid by the revenue of the local district, but by the central government that transfer the money. So therefore, you see this difference of provision of goods that are really truly local, and then goods that are more like national. So that's kind of the argument that we do, why you see this difference between the short-term dynamics, where there is a lot of research about the impact of income on education, but vis-a-vis the long-term dynamics, that is the provision of the public goods that you need for education. No? So with that in mind, that's we have the question for this paper. No? And is to understand what is the impact of the 2011 reform on becoming a mining district, no? So we more or less following our two previous papers use the same data. We have mining data from the for the Ministry of Energy and Mining. We have all the education data from the Ministry of Education in Peru. Just to let you know, there is a standardized testing at the second grade, so we use that. It's done every year. And there is also a school census. And then for the geographical data, the Ministry of Energy has the whole cadastre online, so you can get all the information of the mines in Peru. And the coordinate for the school is based on a database that we have at the IDB, where we, or people of education has georeference all the schools in Peru. No? So we use kind of the same specification that a traditional, if you wish, difference we do. We will do the estimation based a series of covariates. We have students, schools, and district controls, no, based on characteristics of those individuals, no. And then we replicate, but include the interaction with the reform. Sorry, that is small, the table, but let me go quickly to the example. What we found is that after the reform, all the negative effects are not, if you wish, compensated, while all the positive effects are compensated. In other words, after the reform, if you were close to a mine, the positive impact on the short run diminished. Similarly, after the reform, the positive impact of being a district diminished. Similarly, after the reform, the positive impact of being in a mining producing province, also meaning that you are not the district where the mine is, but you are in a district that gets some of the share because of the rules that you get sharing, also the positive impact. So basically, what we found is that the reform reduced all the positive impact that we found before of being a mining producing district or region. No, and there are many specifications. I mean, we only have 15 minutes here, so I'm not going to go to all the details, but we run different specifications with the controls, also different samples of including the whole regions of Peru, only mining producing regions, and the results are consistent across all these specifications. No, so to conclude, because I know that we have few time, is that as in any other country in Latin America, Peru has issues of local capabilities. However, the solution, which, by the way, as Daniela mentioned at the beginning, it has happened before, for example, in Colombia. The solution of taking away revenue is not the solution, because at the end, you diminish the positive impact. If I can use this, if you wish, license, you reduce the joy of mining while keeping the bad things of mining, because as Daniela mentioned in your previous research, people do realize of the negative impacts of environment, so people see the trade-off. We have good impacts and bad impacts. With this reform, you took away the good impacts, no, or reduce the good impacts, and therefore then you go back to the question of conflicts and the ability of access resources. So at the end, that's why we want to call this paper building a state at the local level. At the end, as they say here in the United States, all politics is local, and therefore you cannot escape the dilemma of, or not the dilemma, the challenge of building capabilities at the local level if you want to reduce conflictivity in the mining and therefore access to resources. So with that, thank you. I'm happy to take questions.
Thank you, Osmel. Thank you, Daniela. So we have time. Are there some questions?
I think one kind of cynical view is that, this is true in many countries, I think, that decentralization is basically a way of revenues, a way of kind of local elites, or in some cases even armed groups, to exert more control over mining revenues, because local governments are a lot easier to capture. Do you think that's part of what's happening here, or more broadly, what do you think that's kind of a relevant dynamic in Peru?
That's a very good question, and let me think. Maybe going forward, and let me see that these are not the views of the bank, just to be clear. But as you know, over the last 2-3 years, organized crimes has entered into Peru, no? So I think this is a very good question going forward, no? But in the past, there was not the presence of organized crime, and I think that at the end, at the end, more than local elites is just the issue of services, no? So people do associate, and this is in our other research, people do associate mining, and people, I mean, really, this is survey of people, not elites, no, do associate mining with revenue, employment, welfare. So clearly, people do feel the positive impact of mining, no? And when you take away that income, maybe yes, you're taking away from the elites, but you're also taking money away from the people, no?
Other questions or interventions? Comments? No? So thank you again, Osmel and Daniela, and we'll move to our next speaker, Jonah Rexer from the World Bank. So, Jonah, the floor is yours for 15 minutes.
Thank you. Great, and thanks a lot to the organizers for including me in this program today. This is joint work with Erik Katovich, who's a professor of resource economics at UConn. And in this work, we're going to be discussing the global distribution of critical mining impacts. So I think most of the motivation for this talk is pretty redundant at this point, given the discussions we've had so far. But of course, the kind of build out of clean energy technologies has been accelerating, quite rapidly. You can see just some of the numbers over a 1-year period. There are these kind of massive growth rates for solar, wind, and EV production. And, various forecasts have this expanding 2 to 3 times just in the next few years. And so obviously what this generates is kind of massive demand for critical minerals. And so in particular, when we talk about critical minerals in this talk, one other way we refer to these in the paper is as transition minerals, because we're specifically going to be looking at minerals that are inputs into energy technologies. Of course, many of those fall under the kind of broader grouping of critical. So cobalt, copper, of course, rare earths. These are all inputs into various clean energy technologies, and as a result, the growth in demand for these minerals really directly mirrors the growth in kind of renewable energy capacity as well. And so one thing you can see already is that prices for these minerals have already begun to rise. So here's just a selection of the kind of critical minerals in our data and price series for the minerals. I mean, 2 things really come out. One is that there's an insane amount of volatility in the prices, right? You have these big kind of increases in prices for a lot of these spikes that then crash because new supply comes online, a new kind of large discovery. But when you kind of cut out a lot of that noise and you just look at trends over time, if you look at a price index of all of these minerals, you'll see it's appreciated by about double since the early 2000s in real terms. So what that means, of course, is underlying demand, despite all of the volatility, is kind of generally outpacing supply, and so prices are going up. So what are we going to do in this paper? We argue, of course, and I think this is very consistent with some of the work that was presented earlier, and also work that folks here have done. Is that this price boom really represents both kind of risk and opportunity for the communities where these critical minerals are located. Previous resource booms kind of again presented real trade-offs. Rising incomes, large kind of economic booms locally, At the same time as kind of negative environmental impacts, potentially increases in conflict, although that result may not be entirely strong. But ultimately what we see is that there are these real trade-offs, and this is not kind of an unalloyed good for mining communities. And so this is an incredibly simple and kind of descriptive paper, which just asks kind of what are the economic and environmental impacts of this critical minerals boom on the communities in which these mineral resources are located. So what we do, again, it's really simple. We're basically just going to overlay locations of critical mines from S&P with a bunch of different spatial outcomes from various gridded data products on local economic activity, population, deforestation, other measures of household welfare, and ultimately estimate the impact of mining on these outcomes using basically exogenous price variation. So that kind of volatility, that variation I showed you in the previous chart, is going to be kind of our identifying variation in the study. And perhaps unsurprisingly, I think our results are almost kind of obvious. We identify a very clear kind of environment growth trade-off in the data, where kind of that cumulative roughly doubling of the critical minerals price index over the past 23 years can account for about a 4% reduction in forest cover in mining areas and about a 6% increase in economic activity. So these are not huge numbers, but they are, I think, somewhat meaningful. And if we expect these prices to perhaps double again, these might be reasonable predictions of what we expect to happen as the clean energy transition continues. I think what's perhaps a little bit more interesting and surprising is that we find substantial heterogeneity in this impact. Particularly, we find this kind of environment growth trade-off is strongest, it's most pronounced in places that are very corrupt and have weak governance, and we'll kind of advance a few explanations as to why that might be the case. So let me just kind of briefly go through all of the various data sources we overlay in this paper. Of course, the core of the data is our good friend S&P, who we now know is not very good, but it's kind of the best we have. And there we get the location of the assets, the commodity that's being produced, the timing of opening, all of these good things. We overlay that, with kind of a definition of critical minerals, which we just take from U.S. official definitions. I don't kind of want to belabor that definition. Of course, we've also heard how those are kind of problematic, but that definition really overlaps quite substantially with energy transition inputs. And so that's really what we're focusing on. And of course, our commodity prices come from the pink sheets, as well as some supplemental data sources for kind of rarer commodities. In terms of outcomes, we overlay this mine level data with a whole host of kind of spatial gridded data products. We have projections of GDP. These are all kind of pretty high resolution, about 1 kilometer grid squares. We have projections of local GDP based on nightlights. We have gridded population estimates to kind of estimate impacts on urbanization and population growth. We have data on air pollution, PM 2.5 concentration. We have data on land use, which comes from EU Copernicus satellites, and that's on kind of land cover. That's given us our forest, deforestation measure. And then we also overlay this with a bunch of different welfare measures from DHS surveys, so that we can kind of get external survey-based validation for some of our spatial measures as well. So let me start by just giving you some descriptive statistics on kind of the distribution of critical mines across the world. So the red bars are the kind of, the state of the data in 2022. So let's just, I think, focus on those. You can see, as we, again, already know, there's a, heavy kind of concentration of critical minerals in North America and Asia, and a lot of that is in China. What's interesting is that that kind of broadly reflects the kind of distribution of ownership. So that second chart shows you the home country of the operating firms of these mines, and again, this market is really dominated by the U.S., Canada, Australia, and China. Those are kind of the big mining players, both more generally, but also in critical minerals. One thing that we're really interested in, and we have this kind of a plug for another paper that we're working on ownership structure. On the left-hand chart, C, what we have is kind of the share of assets, or the number of assets that have different ownership structures, so local owners, multinational owners, or joint ventures. And there we see that, in high-income countries, local firms tend to dominate. In low-income countries, joint ventures and multinationals tend to dominate. We have a whole other paper analyzing kind of the welfare implications of different ownership structures in the mining sector. And then lastly, again, something we've already seen several times in this meeting, some of these minerals are very highly concentrated. So here we're plotting the Herfindahl index of ownership and of production of these various minerals, the critical minerals. And the ones that really pop out as super concentrated are like the rare earths, chromite, and zircon. The less concentrated ones, bauxite, tin, coal, although that's not a critical mineral, copper. So there's a lot of distribution and variation in how choked off these kind of supply chains are. So what are we going to look at empirically? It's again an incredibly simple specification where we're just regressing our outcome at the mine level, typically within 25 kilometers of the mine, although we do test robustness to that against the lagged price of that mineral, with mineral and country year fixed effects and a bunch of controls for various time-varying mine level characteristics. And then, again, as I mentioned, we're interested in estimating heterogeneous effects based on kind of local institutional quality. So we interact that price term with this Z variable, which is a measure of basically the prevalence of local corruption. It's called the Subnational Corruption Index. I'll discuss that data in a little more detail in just a minute. But first, I want to just jump to my results. Here we're just, showing you simple scatter plots that give you kind of the partial correlation conditional on these fixed effects between prices and the economic outcome of interest. And what we see here is, again, our environment development trade-off quite clear. There's this negative relationship with forest cover, so as prices rise, deforestation increases. Interestingly, it's more or less flat for air pollution, so there doesn't seem to be a huge kind of polluting effect of kind of expansion in this context, but there is a very clear economic effect. So those prices are highly correlated with both income per capita in the local area, just income, aggregate income, and they're also correlated with population. So we see kind of expansion in many ways as prices rise. There's many mechanisms, of course, that might be driving this. Could be revenues, could be labor market effects. We'll dive into that in a second. But clearly there's kind of economic expansion happening in these critical mining areas. Now, as I mentioned, this is kind of a heterogeneous effect. And so what we have here, my confidence intervals are gone, but that's okay. These are significant, trust me. So what we have here is we've interacted the price term with what we call the Subnational Corruption Index. This is basically a kind of aggregated survey-based measure of corruption that's downscaled to like the ADM1 state level. So it's kind of a subnational variation, so we can keep those country by year fixed effects in. And this is kind of the marginal effects plot, the interaction effect at different levels of subnational corruption. And so what you see is kind of the most corrupt areas are those low corruption scores, so it's kind of an inverted scale. Those are basically places like the DRC, the worst governed parts of Africa. The least corrupt areas where they have the SCI is around 80 is kind of like Switzerland or North America. So this captures basically the entire variation of corruption across the world. And you can see those forest cover impacts are much larger, and the GDP benefits are much larger in kind of the most corrupt areas. One hypothesis that we've hazarded here is that the kind of supply response can be stronger in more corrupt areas where environmental regulations are weaker, where permitting can kind of be easily circumvented. Firms can really respond to prices, and that leads to kind of larger both income and environmental impacts. So the next thing we do is we basically estimate this regression, this kind of time series price regression at the individual mine level for all of the critical 10,000 critical mines in our data, and then we plot this kind of price elasticity of income, and then do the same thing for deforestation. And what's really interesting here is this I think accords quite well with those heterogeneous effects I just showed you. The largest positive impacts are concentrated in Latin America and Africa. Australia is a bit of an outlier in the high-income world, but mostly in higher-income countries you see smaller effects. And similarly for forest loss, again, the largest deforestation effects are concentrated in Central Africa, Peru, and northern South America, and some in the Middle East as well. So generally these kind of line up, I think, quite clearly with those governance relationships that we saw before. And by the way, those governance relationships kind of control for income per capita as well. So we're just kind of isolating the impact of governance, kind of conditional on a level of development. The last thing we try to look at in this paper is, what are some of the economic mechanisms driving economic expansion in response to critical minerals booms? And there's two things we look at. The first three columns of this table, these are survey responses from the demographic and health surveys that are overlaid with S&P data. So we have a much smaller sample here of basically assets where there happened to be a DHS survey in the general area around the time that we have data on that asset. And what you see here is in the first three columns, there's a very clear positive correlation with that DHS wealth score, which is basically an asset index. What this tells us is we're not just picking up night lights that come from immediately the area around the mine or industrial activity that's directly linked to mining. We're picking up a broader increase in living standards that shows up in survey results as well. So that's, I think, a common concern with the night lights. And this kind of rules that out and suggests there's more of a broad-based increase in prosperity that's happening here. And why is it happening? I mean, there could be many reasons, but one thing that we're interested in is the labor market, and we have several other papers that we're kind of looking to expand on this this question. So I think structural change is one potential explanation. As mining becomes more valuable, not only does it draw workers directly into the mining sector, but into input, sectors that are inputs to mining, into kind of allied services sectors, generally out of agriculture. And of course, that deforestation effect also, and the kind of increased environmental damage also kind of pushes people out of agriculture. So, the structural change kind of dynamics might be important in explaining, these increases in prosperity. And so here, our outcome is just the probability of the survey respondent engaging in, non-agricultural employment. And we find that increases, by 10 to 12 percentage points for roughly a doubling in prices. And so that's, actually a very large effect. And so ultimately we think, at least in part, the labor market is explaining, these are higher productivity jobs than subsistence agriculture typically. So that's in part probably kind of what's going on here in driving this broad-based increase in prosperity. So let me just conclude with a kind of simple discussion of implications here. Ultimately, I think one of the main findings here is, the environmental costs as well as the economic benefits really go together. You can't separate this trade-off. And in particular, these are kind of 4 times larger in, for example, the Congo than in the average economy, right? There are very large differences in how responsive local economies and environmental systems are to mining. And I think, this is at least consistent with, although we want to dig a little bit more into this, it's kind of greasing the wheels corruption hypothesis, that these are exactly the areas where it's easier for firms to scale up in response to prices. And so both the benefits and the costs are going to be more severe in those places. What that tells us, I think, in a kind of from a policy standpoint, is that in exactly these kind of weak states, policymakers really need to focus on converting these temporary kind of boom times into longer run development gains. It's not necessarily clear that structural transformation is kind of a permanent state of the economy, particularly when prices ultimately fall, or when the minerals run out. So that seems to be like a first order issue from policymaking standpoint. At the same time, you want to kind of get the good without the bad. You want to mitigate the environmental downside ultimately. And I think that there are a variety of kind of different initiatives out there that can try to help firms internalize some of the costs to the environmental costs, even in contexts where kind of governance itself is relatively weak. And so in the paper we discuss some of these kind of potential policy options. Thank you.
Thank you.
Very interesting analysis. And I apologize if I missed this in your presentation. I'm trying to understand how narrow or broad the implications of your results are, and more specifically, what is the scope? What's critical from which commodities are critical from the perspective of your study? Early on, I understood you to focus narrowly on what I think of as the IEA 7, copper for electrification, lithium, nickel, manganese, cobalt, graphite for batteries, and rare earths for magnets and motors. Done. But later on, I think you referred to the EU and US lists. Now, both of those entities have lists that include 50 to 60 elements, which is basically everything other than iron and coal, if we think about mining. But the US and the EU also have done narrower studies on energy transition elements. And what's the scope, which materials are you focusing on in this study?
Yeah, that's a great question. It's basically, there's a list of kind of, these energy specific minerals. So it's pretty close to the initial list that you gave, plus a handful of others. And it accounts for about 30% of the total number of assets in the data. So yeah, a lot of big kind of production sources like gold and iron and coal, which comprise most of the data, are not included in this. What's interesting though is we do some analysis in the kind of appendix of the paper. We look at kind of mineral specific effects. And we find like pretty similar effects across a broad range of individual commodities. And actually, in a previous version of this paper, this is kind of gone from the paper now, we looked at kind of what we would consider non-critical or non-transition minerals. And you also see kind of similar effects, right? So I don't think there's anything special about the types of minerals, which I think is a point we try to make in the paper, in terms of producing these sets of effects. Of course, certain, when you really drill down, certain minerals might have different kind of pollution profiles or things like that. But kind of on average, you see very similar effects across a broad range of commodities. It's more that the motivation, of course, is understanding how these specific energy transition minerals will, which are growing substantially in demand, will affect local communities, right? So that's more of a framing device, I think, than anything else. But you can think of these as results, I think, as broader than the sample that we use in the paper.
I have a question. Well, first of all, I find this topic between mining and the environment super interesting. I think about it a lot, but also super important. There's two things I abstain from the S&P critiques. I think my point is well made. One thing, these are just more points for elaboration than critiques. One thing that might be interesting is to make a difference between vertical and horizontal minings, because the footprint is different. That's just one thing. Thinking about gold, that's a very different footprint than a nicely organized diamond mine in Botswana. Never mind, there's no forest in Botswana, but just to make a point. What we see actually when we look at the environmental literature, and I don't even mean environmental economy, like full ecology. The biggest issue with forest is actually not the mine, it's the infrastructure to the mine, because that cuts through and that destroys wildlife corridors, etc. And then people settle on the mine, and then agriculture starts to happen on the road. So actually the footprint, the issue with forest is not the mine, but a lot of the land use implications that come from human activity around the mine. That's one thing. So why not try to play with some more advanced forest metrics? Because out of all the environmental metrics we have, forest is one we have most for. And then to the point of mining versus agriculture, because of open pit mining, you have particles in the air that come down on surrounding fields, destroying the harvest. Equally, you have obviously water pollution, mostly along rivers downstream, obviously not upstream, which also destroys harvest. So not only does mining become more attractive, it also agriculture becomes less attractive. Sure. And since you already have DHS, you could easily link it to health, which you should find effects.
Those are great suggestions. I think Aragon and Ruud have a bunch of papers on the agricultural impacts of mining. So I definitely think that, you know, the structural change that we're getting is both kind of push and pull, for sure. In terms of the footprint, I completely agree with you on that as well. You know, a lot of it is actually urbanization around the mining area. It's actually nothing to do with the operations of the mine per se. It's that this booming economic asset is drawing people in. And in another paper, we show some substitution between, you know, forest cover and urban area, or built-up area, basically. So that's not necessarily driven by, you know, mining per se, but rather kind of, and that's again one of these reasons why the costs and benefits are almost kind of mechanically linked, because urbanization is growth, but it's also deforestation, pollution, et cetera.
So following up on that point, so I wondered, in the older studies like Melissa Dell and people like that, they look at one mine and they look at the local effects, and they always have spatial lags. So you try to estimate how far away is the forest being, for example, deforested, is more than 10 kilometers away than 1 kilometer away. And then you can do it for the roads as well, but you have all the spatial maps. So I was surprised not to see spatial lags, and then you would also have the spatial autocorrelation, which you typically have in those studies. So why was that?
For sure, it's not in there yet, but it's something that like we want to add to the robustness tests. You know, we did some very crude versions of that, but they're all relatively narrow bands, just between 5 and 25 kilometers, for example, and we find a little bit of tapering off. Although, you know, I think again because a lot of this is increased urbanization in nearby population centers, you don't necessarily expect to see a huge amount of tapering unless you go quite far out of the footprint. So we should probably put more lags in that if we want to see those. Yeah, exactly.
Let's try to take 2 more questions, one there and one there, and very quick.
I'm just wondering if you've looked at it over longer periods of time, because a lot of this small-scale urbanization around artisanal mining is transitory because they mine out an area and they move on. Have you looked at what the effects of that transitory nature, like they can mine a kilometer-long stretch over a certain number of months and then they keep moving? To what extent does the urbanization and the footprint move?
That's a great question as well. And it is a shortcoming of the identification approach. So just to give a little context, you know, we initially wanted to use kind of mine activity and openings as the shock. And there you're better set up to look at long versus short run effects, because you can just, you know, look at data, various lags from the opening date. But with price shocks, you're almost kind of by design using short run variation for identification. And so just given the data setup, we can't really do that. Part of that is the problem with S&P, because the opening and closing dates for mines in S&P are really totally wrong for the most part. So actually, this would be an interesting use of the spatial data that we heard about yesterday. If those footprints are more accurate over time, we could potentially use that. So this is maybe an area where those two data sets are complementary. But yeah, in our current setup, we can't look at that, unfortunately.
So I like the result on corruption, but I feel, you know, it's begging for more on the mechanism, right? And picking up on Osmel's paper, it would be nice to see whether there's heterogeneity along the line of the institutional arrangement that country have, but also in terms of the market structure of multinational versus state-owned, because otherwise it's a bit lame to talk about how corruption affect emissions without understanding how that plays out, in different contexts. And one cheap comment on income, you say you're controlling for income, and obviously corruption may also be quite correlated with capacity or weaker capacity. So I wonder whether when you do the double interaction, the result survives, as opposed to just controlling for
the interaction between
corruption
and
income,
prices?
And income.
Oh, no, we haven't tried that.
Yeah.
That's a good point.
Yeah, because it might be non-linear.
Yeah, for sure. That's a great point. Thank you. Let me just actually say one thing in response to that. I think we have a separate research agenda, which is much more down the lines of trying to understand the local multinational trade-off and how that interacts with institutional quality. So just to kind of plug other work we have. What we find quite interestingly actually is it makes a big difference, and you find local firms in these markets tend to produce larger economic benefits and also can outperform multinationals in terms of production, which is consistent with other work that I have from Nigeria. And that effect is particularly strong in institutionally weak environments. So there, I think we're getting closer to a mechanism, which is that, the types of firms that are favored in corrupt environments can be very different and deviate substantially from kind of efficiency or the most technologically advanced, multinational firms. So, just to kind of plug that paper, we have, I think, quite a... Yeah, for sure. So
a quick word.
Quick word, sorry. The paper that kind of got me started down this path was work that I did in Nigeria, basically on the oil sector, basically looking at the relative productivities of multinational and local firms in the context of a big indigenization and local content drive, where about half of the sector was divested to Nigerian operators. And what we found kind of counterintuitively was a large increase in productivity in the sector. And that was primarily because we have a bunch of data that shows that those local firms kind of were better able to navigate the political risks, the conflict, the kind of organized crime that was kind of popping up around these assets. And so we think something similar might well be happening in the mining sector as well.
Thank you. So let's move to our last speaker, Cahya, Danu, Rahman, online. So, Cahya, can you hear us?
Yes, can you hear my voice?
Yes, so we can see you. Just wait a few seconds so that we can see your presentation on the screen. Okay, that's perfect. So the floor is yours.
Okay, thank you. Good afternoon, honorable reviewers, panelists, fellow presenters, colleagues. It's an honor to be here today and to have the opportunity to present my research about nickel downstream in Indonesia. Before I start the presentation, I want to apologize if my second language, English, is not good enough. And I want to apologize if my connection is unstable. Almost all area in where I live has been affected by power outage and poor internet connection due to widespread flooding. My name is Cahya Danu Rahman. I'm from Gadjah Mada University and now active as a statistician in BPS Statistik Indonesia. Today, I will present our research titled Nickel Downstream, the Impact of Nickel Smelter Development on Household Welfare in Indonesia. This study evaluates whether Indonesia's nickel industrialization policy of often celebrated at a macro level actually translate into real welfare improvements at household level, and whether those gains are equitably distributed. We all know that Indonesia holds the world's largest nickel reserves and contributes nearly half of global nickel production in 2023. Approximately 90% of Indonesia's nickel reserves are concentrated in 4 provinces: Central Sulawesi, South Sulawesi, Southeast Sulawesi, and North Maluku. In response to this abundance of mineral resources, the government has enforced a nickel ore export ban and encouraged domestic smelter development in 2015. The goals are move up the global value chain, attract manufacturing investment, create jobs, and improve welfare. As part of this policy, large-scale nickel smelter development have been established in Morowali, North Morowali, Konawe, South Halmahera, and Central Halmahera. These industrial zones have rapidly transformed in the economic landscape of each region and attracting massive investment flow. The presence of nickel smelter has contributed significantly to improving the economy in each regency. However, welfare outcomes in smelter regions are not uniform. Some regions experience welfare gains, others face rising costs and limited local benefit. Official statistics indicate that poverty reduction associated with smelter operation has not occurred uniformly. Morowali and Konawe, for instance, have recorded marked improvements, whereas Central Halmahera and South Halmahera have experienced less favorable outcomes. Poverty reduction in Central Halmahera appears to have stagnated despite the smelter beginning operation there. Moreover, poverty in South Halmahera has actually increased since the nickel smelter began operating. These results raise a critical question. The first is, does the development of nickel downstream industry have an impact on household welfare? And the second is, are benefits equitably distributed across income group? We apply the ID framework to identify causal effects, comparing its treated regencies, those hosting nickel smelters, with carefully selected comparison regencies that share similar socioeconomic characteristics before the intervention. Additionally, we complement the causal analysis with growth incident curves to assess how welfare gains or losses are distributed across the household expenditure spectrum, from the poorest to the richest households, following the framework of Raffalian and Chen. The ID estimation was applied in each treatment regency: Morowali, North Morowali, Konawe, South Halmahera, and Central Halmahera. The selection of comparison regency was based on the assumption of parallel trends in the estimated main outcomes. As an initial identification, macro indicators were used to examine the similarities between the treatment regency and the comparison regency. We use PCA to calculate the weight of each indicator and conducted a different test for each indicator. Based on the result of testing, the selected comparison regencies are SIGI for Morowali, POSO for North Morowali, MUNA for Konawe, East Halmahera for South Halmahera, and North Halmahera for Central Halmahera. This study utilized Susanna's household survey data from 2014 to 2022. And the primary outcome variable or the proxy household welfare is household per capita consumption expenditure. According to Houghton and Kenker, welfare is defined as the extent to which households have control over various commodities. And Dayton states in his research that one indicator that can represent this is per capita expenditure. Then we move to the main result of this research. Based on the ID estimation results, we can conclude that the operation of nickel smelters can improve welfare in 4 regions. And the strongest welfare improvement occur in Morowali and Konawe. The presence of nickel smelters increased average of per capita household expenditure in Morowali and Konawe around 15.5% and 11.7%. In Morowali, formal employment rose from 30.4 to 34.5%. And in Konawe, it increased even more sharply, from 27 to 37.6%. We also see rising urbanization reflecting growing economic activity around industrial zones. This changing indicate that nickel downstream has stimulated job creation, strengthened local economy, and contribute to the higher household welfare. In contrast, Central Halmahera exhibit a significant welfare decline in per capita household expenditure of around 13%. Nickel smelters are not optimal in creating many jobs for lower middle class. Based on process data, Susanas data, the formal employment slightly decreased from 33.4 to 30%. At the same time, the number of micro and small enterprise as well as their total revenue shows a downward trend after smelters operation. Consistent with previous studies, inadequate governance and weak local linkage mean that extractive industry can reduce rather than improve community welfare in this region. And we move to the GIC. The GIC analysis indicates that household per capita expenditure grew relatively evenly across income groups before smelter operation, although South and Central Halmahera show early sign of inequality with higher income households spending more than others. During the initial 1 to 2 years of smelting activity, growth becomes strongly pro-poor, as lower and middle income households experience faster than expenditure increases, likely due to expanding informal income opportunities and rising local demand. However, this pattern gradually reverses. Over time, higher income households capture a large share of welfare gains, supported by better access to skilled and formal jobs, greater capacity to invest business opportunities, and greater the ability to accumulate assets, particularly housing and land in South and Halmahera. Growth among lower income households also slow relative to upper income groups. And then our findings show that economic impact of nickel downstream differ across regions. In general, downstream stimulates growth through industrial clustering and multiplier effect in supporting sectors. This is reflected in the sharp of increase in GDRP and the rising share of manufacturing in regional economies. For example, Morowali's GDRP increased nearly double, and Central Halmahera manufacturing share jumped from 6 to 54%. This result highlights strong economic transformation. However, the extent to which these economic gains translate into household welfare remains dependent on local governance, labor absorption, and the strength of supporting sector. Despite the economic gains generated by nickel downstream, our findings also highlight several challenges. Many regions face a shortage of skilled labor. Many households in the smelter region have low education level, limiting their access to skilled and formal sector jobs. And after that, South Halmahera and Central Halmahera show little improvement in formal employment. In addition, governance and planning gaps hinder the ability of local communities to fully benefit from smelter. These challenges should be addressed to ensure a more inclusive outcome. Our findings point to several policy directions. The first is improving local workforce skills is essential to ensure residents can access better jobs in the downstream industry. And the second is strengthening local MSME participation can expand economic linkage beyond the smelter area. And the third is promoting equitable regional development is crucial, as welfare impact remain uneven. And the conclusion of this research is this study shows that nickel downstream has the potential to improve household welfare, but the effects are uneven across regions and income groups. Therefore, the long-term success of mineral industrialization depends not only smelter facilities, but also on strong policy coordination, human capital investment, and inclusive regional development strategies. Thank you for your attention. I hope this study provides useful insight and for policymakers. Thank you.
Thanks a lot, and I apologize for my pronunciation of your name at the beginning. So let's take some questions.
Thank you for your presentation. I was wondering if in the difference between your different regions, did you notice any, like if you notice similar path or different paths regarding internal mobility and internal migration towards this specific region? Did you experience, for instance, for Halmera, you saw that you have a negative effect on the welfare, right? Is there any pattern of internal migration specific to that area or not? Or if it's the same similar pattern in terms of internal migration?
Then what? Internal migration? Or?
Yes. If you notice the same pattern in terms of internal migration toward the different region where the smelter were installed.
Sorry. My English is not good enough. Sorry.
I'm going to take another question.
Can you explain more clearly, please?
More clearly.
Sorry.
No problem. So can you tell us more about where the smelters are located, and how is the the redistribution of this rents allocated across different provinces? Tell us a bit more about the context.
Yes. In this research, the context of this research, right?
No, just in general. Where are the smelter located in Indonesia, and what is the fiscal institution which are helping to reallocate the rents?
Oh, why? In this research, located smelter is in 5 areas. In Indonesia, only 5 regions is that have been established smelters by a government, because in this area have nickel reserve many nickel reserve than others area in same location in that province.
So thank you all. A big thank to all of our speakers, and I think that's time for lunch. So thank you all.
Sorry for